5.6 Part B video is brought to you by really old red Lego spaceman with faded eyes, and this bothers me that he has different colored hands. But I haven't taken the time to fix these Lego men. At any rate, so we're going to continue with some more applications. This is a type of interest that I have not seen in the real world. Continuously compounded interest. It follows that exponential growth function. If you've forgotten what that is, it's P of t equals P naught e to the kt, where each thing is what it's supposed to be, right? So we are going to invest 20,000 into this account. Well, 20,000 is the initial amount, the amount at time 0. It's compounded continuously, so we know E. If you recall, there was this other one, P times 1 plus R over N for the NT. This was in compounds per year. This is the more common one that's actually used by most banks. So the question here is, what interest rate do you require in order to have $2,500 in 5 years? Note, in this case, we don't know K, but we now know T, P naught, and P of T. So I'm going to list those other values over here. P of T, and really I shouldn't put T here, I should say P of 5 equals 2,500. So then we just plug this mess in here. We got 2,500 equals 2,000 e to the, we don't know the interest rate, times 5. Well, this turns out to be the same problem we did right at the end of the last video, where we had 1 million bacteria and we were solving for it. This is an exponential equation. How do I know? There's a variable as an exponent. So let's solve this for K. Note, we'll divide both sides by 20,000. That means we can lop off these zeros, and we would get 25 over 20 equals e to the 5k. Pick a logarithm. As I said last time, pick a logarithm base e, because that fits nicely with this base. It leaves our left side as 5k, and I'll go ahead and simplify 25 over 20 now, just because it's now 5/4, because 25 divided by 5 is 5, and 28 divided by 5 is 4. Note K, the interest rate we're looking for, is the natural log of 5/4 divided by 5. Now, there's another way we could write this. We could say K is equal to the natural log of 5 minus the natural log of 4 divided by 5, but honestly, both of these representations are quite useless. If your bank said, I will give you this amount of interest, you'd say, well, what is that? Is it worth running it? So let's get that approximation. This first one is less writing. Natural log 5 divided by 4, and then all that divided by 5. I'm looking at 0.04462877103. So at some point the rounding isn't going to matter. If we rounded to this decimal, you're going to be shortchanged interest. If you round to this decimal, you're going to get more interest than you're supposed to. Here you're shortchanging, but even less. So, it's up to you. I would say let's call this approximately 4.463% interest is what you'd be earning to take 5 years to come up with $25,000. If you want to check how accurate, like how close this is, just plug this number in here and see how close you get to 25, either above or below. This one is going to be slightly above because we rounded up on that 2. All right, so we're going to use this same rate, and we're going to ask, how long is it going to take to double your initial investment? Well, if our initial investment is 2,000, we're going to say the doubling, the P of T, is going to end up being 4,000. That's how we would double it. And we're using this K. Now, I'm going to keep it exact, so I'm going to put this K in, use my calculator with this so I don't have any rounding, and then round at the very end. So watch this mess. I'm going to show you a trick right after this. So we get 4,000 equals 2,000, the initial investment, times natural log of 5/4 divided by 5 times T. Note, all of this is an exponent on E. Now look at this. When I divide both sides by 2,000, I get exactly 2. Seems like there's a connection between the number 2 and the word double, right? Raise your hand if you know what it is. So that equals e to the, again, this natural log. I don't want to rewrite it. I want to just write K, but that often confuses students, so I won't. So it's this. Well, Note we have an exponential function equal to a value. To solve it, we take logarithm of both sides. Any base we choose, we could take log 10 if we wanted to. I'm going to choose natural log because there's a connection between this base and that base. When the bases are the same, the result is the exponent. So this becomes natural log of 5/4 divided by 5 times t equals natural log of 2. Well, divide both sides by this gross number, which remember was approximately this, but I don't want to approximate to the very end because exponential things are quite sensitive to approximations. So this becomes natural log of 2 divided by natural log of 5/4 divided by 5. I'll just smash all that into my calculator. We could do a bunch of different simplifications of that if we wanted to, but why? There's not any much value in it. So natural log of 2 divided by natural log of 5 divided by 4 divided by 5 gets us, oh boy, what? 0.621256. Okay, so this is totally wrong. I got to find my mistake here. Let me check something. I'm just a little bit embarrassed, not totally, because if I was super embarrassed, I would just delete this video and restart, right? But I'm not going to. There we go, right? I needed parentheses around this denominator to get it divided right. I should be able to explain why, but I'm slipping my mind at the moment. I'm too lazy to think about it at the moment. So here's what it is. 15.531 years. I knew that 0.621 was not correct because if I looked back up here, it took 5 years to make $500. That's nowhere near doubling. So to get to that doubling, I knew it had to be more than 5 years. And it ends up being about 15 years. Okay, for those of you who saw the connection, you rose your hand when you saw that 2 and doubling, there's a reason that this is always going to be true when he asks you to double. Because it doesn't matter how much we invest. Watch this. If we want twice our investment, and I divide both sides by the initial amount, we're left with 2 equals e to the kt. So if I solve this thing, I'll take natural log of both sides, and I'll get natural log of 2 equals kt. So if we want to know the interest rate, given a specific amount of time, you would divide both sides by that t. Here's this one. If we want the time, given a particular interest rate, we divide both sides by k. Here's that one. And you've got everything you need. So this is a nice, handy little way to find doubling time or growth rate. Note that this value for k is always going to be positive because it's growth. Isn't that wonderful? Here, let me make sure you see that.